Okay, so thank you very much for coming to the Brown Bag today. Sky, would you care to begin?
Yeah, great. Thanks, Steve, and thank you all for the opportunity to chat today. I perhaps retitled things a little bit for this first slide. Are the slides coming across the WebEx okay, Steve?
Yes, they are.
Okay, great. So we're going to focus on
the conference is in lecture mode.
So we're going to focus on the geospatial aspects of Sciencebase and show a few demos, kind of talk through some of that here today. There are a lot of other aspects to Sciencebase and things there, but we're going to really just focus on the geospatial parts of things. As an agenda for today, I'm going to give a quick introduction of the what, why, when, and how of Sciencebase, sort of what it is, how it's come about, show a slide that kind of walks through a number of the kind of major architectural pieces just to give you some context on everything. I'm going to pass the ball over to Don Brown. From there, he's going to take some time, walk through the geospatial data repository and services aspects of things, show some demos from that, talk about our GIS share capability, and really focus in on the ArcGIS interactions then with Sciencebase from there. He'll pass it back over to me. I'll talk a little bit about how Sciencebase acts as a database and focus on the idea of collection services and how those are interfaced with as spatial services that may be of interest, and some things on discovery. Tim Kern will pick it up from there, talk about some of our current challenges and thinking about where we're going with some things here in the next little while, and then I'll do a little bit of a wrap-up and open it up for discussion amongst the group. So a little bit on Sciencebase and its origins and history. Some of you may be very familiar with this because you're actively working with some part of Sciencebase, or you're part of a community, and there some of you may be tangentially familiar because maybe you're part of something that's actually powered by Sciencebase, whether you know it or not, behind the scenes in terms of some of that architecture being used. But this really all started back in 2006 with the thing called the Bureau Science Thrust that some of you may know about, things like the Integrated Landscape Modeling, or Monitoring, I think as it was called at that time, thrust, the Fire Science Thrust. There was a water availability thrust in the Flint River area, and a couple of other efforts like that around the Bureau. And that was really the first opportunity that we had from what was the Geospatial Information Office at that time to sit down and start figuring out, okay, what kind of capabilities do we need to put on the ground to support the interactions of science teams and what they're doing. And we had a vision for MyUSGS at that time that included a couple things that ended up morphing their way into what ultimately became Sciencebase. We called it the Data Explorer and the Data Uploader. And I think in my own personal space out in Confluence, I've got some of the early seminal documents that went into some of that if you're interested. Then over time, we kind of took those two ideas and we ended up coming up with this idea of a science data catalog, which ultimately got called the Comprehensive Science Catalog. There's a little bit of a bureaucratic story I could tell you on that, but I'll probably skip that today. But that first iteration of things was built on the National Map Catalog technology that Rick Brown, Jeff Wendell, and quite a number of other folks out of the Rolla Center had built for one thrust of the national map at a time, and I'm sure some of you may know a lot more of that history than I do. But we really leveraged a bunch of that technology. We brought it into play, and we started building out what we initially called the Science Data Catalog, or Scientific Data Catalog, at the time, and then we started calling it the Comprehensive Science Catalog because that was a little bit more palatable to some folks to be thinking about. All of that led then over time and kind of the evolution of a program and trying to really work this thing up into what became Sciencebase 1 and now Sciencebase 2. I throw this little term in here, everything is miscellaneous, because that's really one of the sort of base level foundational concepts that we followed in the Sciencebase world, is that at the end of the day, you get a science team together, they don't just need a catalog of data, they need a catalog and a repository of a whole bunch of other things. They need their scientific publications and journal articles that are important from a bibliographic sense to what they're doing. They need records about projects that are going on. They need records about a lot of different things brought together in one place. And so that really formed a lot of the basis for the Sciencebase model and the ideas that we've come up there, that everything is an item, and an item can be data, an item can be different kinds of data, an item can be a record about a project, an item can be a lot of different things. And so that really came together there. And now we're working toward what we've codenamed the Constellation Edition of Sciencebase, which will be building on a lot of the lessons learned from our Sciencebase 2 experience, the things that we've done with MongoDB and Elasticsearch and some of the other capabilities there, and really building toward a different type of architecture that brings together a lot of different kinds of databases into one overall system. But I'm not really going to go too much into all of that. The bottom line message that I want to give you here is that Sciencebase has always been driven at the ground level by user stories. We actually struggled for quite a while when we were sort of being pushed toward this idea of a comprehensive science catalog, this place that would be the end-all and be-all for everything. We were going to catalog and bring together all the data that USGS has, no matter where it happens to be. That's a really tall order, and it's really not something that's even all that practical in a lot of ways. Although we're kind of being pushed toward that now, we're being slowly moved along this path through things like the open data initiatives from the White House and OMB that are kind of pushing us down that track. But really, Sciencebase is driven by user stories that we get through the different communities that we interact with, from a small project to a big initiative of some kind, both inside the USGS and connected to the USGS. So we have partners that involve university folks, partners that involve other Department of Interior organizations, other government organizations that are really a part of the various communities that are working within the Sciencebase realm in some way. And our development is really very much driven by the needs that are expressed by those users. And so it's very much a grassroots kind of effort as the whole thing moves forward. So you'll see some things in Sciencebase sometimes that people scratch their heads at and go, well, why'd you do it that way? Or, you seem to be missing this one kind of piece with things. Why is that? It's really because of the development history. And we've been fairly much an open book on this for a long time. If you have a MyUSGS account, you can get access to the Sciencebase JIRA project that has several thousand items in it that really track the development history, and a lot of conversation back and forth on why we did what we did and what has happened in that project over time. So I'm not going to go into all of the details on this slide. Obviously, there's a lot of different things here. I'm going to mostly focus on the aspects of the Sciencebase architecture that relate to geospatial that you're going to see here in a couple of minutes, tee those up a little bit for Don to talk about, and I'll talk about a couple of aspects of those as well as Tim. This is a slide I put together recently for a couple of different events with ESIP, the Earth Science Information Partners, laying out what Sciencebase is and what's really behind that. The major pieces of this are that we've got over here on the left data file inputs. There are different ways of uploading data into Sciencebase via files that can be uploaded either via form interface that we have or via an API. There are different kinds of metadata item inputs in terms of just bringing metadata in. Basically, as I said earlier, everything is an item. An item can have data attached to it as a file. It can be pointing to data services somewhere else, or it can be metadata that describes things in various ways. We're dealing with a lot of different kinds of metadata and flavors of metadata and ways of getting items into Sciencebase via the API, via forms, via customized form applications. There are a lot of ways of doing that, and we talk about some of those here. What Don's going to show you are some of the specifics around geospatial data and what happens to those data coming into Sciencebase. This middle piece here, the Sciencebase tech stack, these are kind of the major components of it. The metabase based on a MongoDB base, the complex geometry store that we still use PostGIS in there, although we're taking a look at some of the developments in the MongoDB world in terms of dealing with more complex geometry. A lot is based around what we can do in the search index that we've based on Elasticsearch technology at this time. And then there are a number of other pieces in the stack from GeoServer, GeoTools, ArcGIS Server. Don's going to hit on both of those. There's a Java image library component. Actually, there are a number of other library components that are used there, and loosely coupled in right now, but working its way into deeper engineering is Threads Data Server, dealing with OpenDAP grid data. There's a whole service layer really built into the outbound API, the outbound piece of things, that includes metadata services from our own Sciencebase REST API to OGC CSW, PMH, OpenSearch, those standard methods of getting access to the metadata pieces, to some data services from compressed downloads to some GIS-specific services that Don will show here in a few minutes as well. And again, loosely coupled in there, but on its way toward being engineered into the full stack is OpenDAP via Threads Data Server. We have a number of different interfaces then kind of downstream from all of this. We've got our primary outputs of HTML landing pages that we've done some things like embed schema.org metadata into, our own Sciencebase JSON, an ISO metadata output that we're continuing to improve over time that really takes the abstract metadata model of the Sciencebase item and converts all of those to ISO metadata. And then we also have outputs to Atom, mods, which is a library-specific feed, a CSV option that gets you certain metadata, and then CSDGM as an output as well. There are quite a number of different downstream uses that are going on from some Drupal sites like the National Climate Change and Wildlife Science Center and a few others that are cropping up out there that are using some custom Drupal modules, Python and R methods that Tim is going to hit on here in a little bit, jQuery and some other kind of similar front ends that can run anywhere, some CSW search things I'll mention here in just a bit, and some ArcGIS desktop interactions that Don's going to get into here in a couple minutes as well. So we're going to kind of focus in this area of some of the inputs, what happens to those in terms of how they're served out, and some of the downstream uses of those things as we go through. And I'm going to toss the ball over to Don here, who's going to do a demo and get into the next pieces of things. Okay, Don, you should have the ball.
All right, I have it. Thanks for the intro, Scott. All right. And you see my desktop with the Sciencebase landing page.
Yes, Don, go ahead.
All right, thanks. So for those who are not familiar with Sciencebase, here is the landing page of Sciencebase. So we'll focus on the GIS capabilities of Sciencebase. So the main functionalities of Sciencebase in that realm are, it kind of combines the capabilities of like a Windows Explorer, an ARC catalog, and a fancy FTP site all in one. And I'll just get started in showing you how to add items to Sciencebase and showing you all the capabilities it has. So right now, I'm just in my own space, and I'll go in and add a new folder to my space where I'll store all this demo data. I'll just call it demo and create a new folder. Folders are called items in Sciencebase. How Sky touched on, everything is an item in Sciencebase that you can add to. So I'll go into my new item, and then I'll say, I want to add a new item inside of here, and I'll say it gives you two choices. You can either import a file. This is a file you have access to locally. It's actual data you're uploading, or you can say you want to create a new record, which is more of a metadata sort of record where you point to data which is on some other server. So I'll import an actual file from my local system. I will grab all the files included in my shapefile here. I'll say open, and it uploads my shapefile files into Sciencebase. You're probably familiar, a shapefile consists of a lot of different files. When I say done uploading, Sciencebase recognizes that it has an actual FGDC compliant metadata attached to it, and it tries to parse some of the data out of that and place it into the Sciencebase brand of metadata. So I'll say that's fine and allow Sciencebase to do that. As you can see, it takes those fields and puts it into Sciencebase. So the only thing we require you to do when you upload an item to Sciencebase is give it a title. This should be a meaningful title because it helps other users search for your data in the future. This title is not very good. I'm just doing one really quickly, but you get the idea. After I click Save, Sciencebase actually starts an instance of this, a GIS service of this shapefile on what's called GeoServer, and that's how we are presenting a map of this data. GeoServer is an open source GIS server that Sciencebase utilizes. So we started using it initially just to show a map of the shapefile you uploaded. So Sciencebase displays that map, but you can also click on the interactive mapper, and you can get a small mapper where you can zoom in and out of your data so you can get a good look at what you upload, and so other people can look at your data to see if that's maybe what they want to download or not. So Sciencebase is kind of consuming its own services from GeoServer, and then we had some end-user stories that say, why don't you make these services available to other people? So we created this advanced services link where we make these service endpoints available for people to use in third-party applications. So GeoServer uses the open source GIS services format. It uses what's called WMS and WFS for vector format. WMS stands for a web mapping service. That is essentially pictures of your GIS data. It's not serving all the coordinates and everything behind the scenes. It's just serving a picture of your data to display in a third-party application. One way to consume this service is to copy the URL. You can go into an ARC catalog session. You can say you want to add a WMS server. You paste in the URL. You see the layers in that WMS service. Click OK, and you can drill down and see your data right in ArcGIS Client, and use it interactively. And then the other service, the WFS service, stands for a Web Feature Service, which actually serves the data. It's not just pictures of your data. It's all the coordinates and everything, so you can actually read it into Geoprocessing Services and other things. So if you want to consume this in ArcGIS Client, you would copy that URL, go back into Arc Catalog, use the Interoperability Connections tool, and you would paste in your URL. And you go into the parameters. You would click the layers you are interested in, and then click OK, and then it would make your connection. And then this is actually a live connection to the data. You can use it interactively. It's not just pictures of the data. And as it reads it in the first time you click on it. And so you get an actual picture of your data, and you can add this data to a session of ArcMap to combine it with other data you have locally. And you can actually use this kind of like a local shapefile. You can actually change the symbology on it and other things like that. And you can also read it directly into geoprocessing toolboxes. So you want to do a clip on this data, you can just add this data directly to that tool and read it interactively without having to download the data to your computer. And you can also read it into standalone Python scripts and other things like that to do any kind of processing you want on the data. So back into Sciencebase here. So that's the open source services for vector data sets, which is shapefile here. I'll now go demonstrate how you can use this functionality with raster data sets. So I'd go back into my demo folder here, click Add Item again, and I'll go find a raster on my local file system here. Click Open. Right now, Sciencebase mainly just reads GeoTIFF format. There's talk in the future that we will read other formats using the GDAL extension of GeoServer to read other formats. But right now, it's limited to TIFF files. I'll just call it sample raster for now. Click Save. So once again, this starts up a GIS service on GeoServer, and you can see a picture of your raster here. You can use the interactive mapper just like you use with shapefiles. And you can click on the Advanced Services link again, and you get the WMS service, which serves pictures of your raster data. And then in addition to what you got with vector data sets, you also get what's called a WCS, which stands for a Web Coverage Service, which is just it's the way it serves the data behind the scenes for rasters instead of vectors. So you can consume that in all kinds of third-party applications also. So with that, I think I'll go into how you can actually start a GIS service based on the ESRI format now. So Sciencebase also utilizes an ArcGIS server behind the scenes. So to demo that, I will go into ArcMap. Let me start a new session here. Let me find an ArcMap session that I already saved. You can develop your map however you want. When you get it the way you want it to look, you would go up to File and click Share as a Service. Save a service definition file. You want to include all your data behind the scenes. I'm just doing this really quick to show you the possibilities. You don't have to remember all this. You would click Analyze, and this is a step that analyzes your ArcMap document to make sure it doesn't have any capabilities that are not compatible with ArcGIS Server. So after you work through any errors there, you click Stage, and what this does is create what's called a service definition file. So it's essentially your map document and all the data behind the scenes and some configuration files all wrapped up into one file. So after you add that service definition file, then you go back into Sciencebase and you would go back into Add Item, and you would just upload that service definition file to Sciencebase. And here it is. It is a .sd extension, and I would click Open. Done uploading. Give it a title there and click Save. So what Sciencebase is doing right now, it is saving that service definition file, and it is unzipping it, and it is also making a call to the ArcGIS server to start an ArcGIS mapping service instance behind the scenes. So while it takes a minute or two to develop that, in the meantime, I can show you that this service definition file is here for download, just like any other file you upload to Sciencebase. You can click on this service definition file and click you want to save the file, and click anywhere that you want to save it. So if I were to save it on my local hard drive, I can actually unzip this service definition file, and then I have access to all the data or all your end users have access to everything you just uploaded. They have access to MXD, which they can open, and it would open up all the data included with it, or there's just standalone data is in here too, and available for people to use. So it looks like it's still thinking about starting this ArcGIS service. After it completes starting this ArcGIS service, you would go to the Advanced Services link again. I'll show you a sample of after it actually completes starting that. You would get an additional URL here called an ArcGIS REST service in addition to those open source links that I showed you already. So you can copy that map server link from our ArcGIS server, and you can also use this in all sorts of third-party applications. For example, you can use it in a databasin. I don't know if a lot of you are familiar with that, but you can import a data set into databasin. You just say import a map service and paste in the URL there and consume it there. You can use it in ArcGIS Online Mapper by saying adding a layer from the web and paste in the URL there. Another example is the national map. You can say you want to add data in here, say it's an ArcGIS server, and you paste in your URL there, and you hit connect, and you can view all your data online there. So you can consume it in any kind of third-party applications. You can also consume this in ArcGIS Desktop. And then that's most of the things for the ArcGIS service. The other thing I wanted to explain is the Gis Share, which we are kind of labeling as the functionality to be able to edit data through the internet through ArcGIS server. So Right now it's kind of a manual process. People tell us if they want to be able to do that, and we make their services into a feature access service. So after they tell us they want to be able to do that, they can actually edit the data online. You can edit data in ArcGIS Desktop, or we can make online applications, or there's other third-party applications to edit that data. Here's one example of an online data editor. It's kind of a crowdsourcing technology to get all different kinds of people to edit the same data set and have access to it. They wouldn't have to have any type of special client software. All they would have to have is an internet browser and an internet connection. So here's just some sample data of some well pads. You can actually add new data to this, fill in data to complete the attribute table and things like that. You can see the attributes of old data, delete old data, add data, and things like that. And this is not just drawing pretty pictures on your computer. This is actually editing an SDE-enabled enterprise database behind the scenes. So it's pretty powerful, and a lot of people can change data sets in a very quick period of time.
Don, do you mind if we pause for questions?
Yep, that was a very good place to stop.
Okay, hang on. Let me take it off of lecture mode.
The conference is no longer in lecture mode.
Alicia, did you have a question for Don? Well, Don, Alicia, I think had a question for you. Are coverages a data type that you can upload to Sciencebase?
Coverage is our well, you can upload any file you want to Sciencebase. Whether it shows a map of that data and creates GIS services of that data is another question. Coverages is a file type that we would not be able to actually read and show a map of or create GIS services from. That's kind of an older format. I think, yeah, a lot of people still use it, but you could actually upload those data and people could download it and use it locally. But yeah, we wouldn't be able to create GIS services for that currently. But if there's a lot of user stories that want to be able to use that, it could always be incorporated in the future.
Yeah, this is Sky. I mean, at some point in the not too distant future, somebody, either us or some combination of folks, and I'll talk a little bit about the collaborative development nature of this in a little while, are going to have to deal with that. You know, we have a fairly large collection of published ARC coverage files that are sitting out, say, in the NatWeb space from USGS series pubs and whatnot, that, you know, at some point somebody needs to do kind of the forward migration work on those, get those into a more accessible format, maybe as services or as other kinds of downloads, you know, for kind of broader use into the future. And that's kind of a corporate question that I think USGS is going to have to answer at some point.
Okay, Roland is asking whether Esri grid format can be utilized by Sciencebase.
That would be the same answer for that one.
Okay.
Yeah, I mean, we've got a user story right now that's driving us toward the GeoServer support for Mr. Sid, because we've got to get a number of files from a couple different projects accessible via other services for that. But really right now it's shapefiles, service definitions, geotiffs are really the major ones that are available there. There is an image server capability that'll basically take any kind of image file, almost any kind of image file that you upload, and provide it back out to you via dynamic service that'll give you, you know, downscaling, some image conversion, and you know, different formats and different scales of that image from there. But really, in terms of specialized file handling, that's what Sciencebase supports currently.
And let me add to that, with the service definition file upload, you can have that actually uses ArcGIS Server, and anything that ArcGIS Server can read can be uploaded in your service definition file. So if coverage or an ESRI grid is incorporated When you create your service definition, then that is fine to upload, and that will be read by ArcGIS Server and served as a mapping service.
Right, really good point.
Okay, I would encourage people to unmute their phones and stop chatting me privately, but let's see what else we have here. Are there any storage limits in Sciencebase?
Yeah, I was going to address that at the end, but I'll answer that now. I mean, yes, there are practical storage limits. You know, we're working toward you know, a cloud-based version of this as the department and everything kind of gets their act together around what the cloud services are going to look like. We've got some early prototypes working out in that space, and you know, so for some intents and purposes, we should be able to grow as much as we need to over time. The real question comes down to one of scope and scale. You know, how big can we, you know, really reasonably make this thing? Who's going to fund it over time? Sciencebase is a part of the Core Science Analytics and Synthesis Group, which is part of the Core Science Systems mission area. It's a core component of our architecture. We're using it to serve a lot of our own needs and capabilities within the Core Science Systems mission area, as well as a lot of other partner projects beyond us in some ways. We've been asked in different times to maybe come up with some kind of a subscription model or some sort of a shared cost model, both by, you know, our management as well as by folks who would like to, you know, be part of that subscription model and wouldn't mind paying a little bit of money, say, to get some space and be part of all of that. We just haven't completely tackled that end of things to come up with a reasonable model for doing this. At this point, we basically will, you know, take on, you know, new interesting partners who have the need for some capabilities here, who are maybe a part of something that we have going on, like our support for the John Wesley Powell Center or some of the other groups that are out there. But it's kind of a case-by-case basis at this point. There's some work sort of organizationally to explore with a number of science centers throughout the USGS this year what a future business model might look like for this service, and really carry forward a message to the executive leadership team on, you know, hey, we think this is a capability that a lot of folks in USGS could leverage. You know, we would like to see some solid bureau support for this, as well as folks who are willing to put some money into the coffer to help pay for storage and operations and all those kinds of things that go on.
Okay. Let's see. I think you might.
So, Sky, so what is the physical limit at this time?
Well, I don't know. We've got a number of terabytes to grow into as necessary. I mean, we can't, you know, take on massive new collections at this point, but
right.
You know,
but for like, say, an individual file.
That's sort of, we're going to talk about that a little later, but the individual file limit is generally tied to, for upload, is generally tied to the fact that we use HTTP for our file upload through Core Sciencebase, and that's about 4 gig. If we move to, as Sky pointed out, that we have some pilots going on using some other conventions, and there are far fewer limits, far greater limits on that file transfer. So we have a slide on that a little later.
Okay, thanks, Tim.
This is Al Ray. I have a question about access. And okay, so is everything that you put on here shared to everyone in the world, or do you have the ability to share with just a group, or what?
Yeah, we built that in from the very beginning as a security framework, and I'm going to talk a little bit about the hierarchy here in just a minute that provides sort of inheritance of permissions on down. But any given item in Sciencebase can be locked down to you as an individual or shared with your colleagues either inside the USGS or outside the USGS as needed. It uses the Active Directory system for authentication and access control for all of the Department of Interior, just like MyUSGS or any of the other systems that we have out there, plus the MyUSGS space of external user accounts, and there are several thousand of those that have collaborated with us in the various systems over time. and a method for, requesting those new accounts and that sort of thing. There are a number of refinements that we look toward in the future in terms of tying this to the data release process that is continuing to be refined in the USGS, so that, say when you have something that's only available internally and then you go to make it public, what actually has to happen there in terms of you declaring that, this thing has been through appropriate review at your science center, or bureau approval as needed for the materials going out. Right now, that's part of why we're limiting this a little bit and not just making it a free-for-all of, everybody can, come in here and participate, because we kind of need to understand who we're working with, have a little bit of a conversation on, what you need to make sure you're doing at your science center level to, make sure that any of the things that you're putting out publicly really can be public. But we've built in the architecture to support security all the way down to the individual item level. Either shared with you, shared with your colleagues, shared with the USGS. There's a role for all of USGS, or shared publicly beyond that.
Cool. Yeah, thanks.
This is Doug Freehafer in the New York Water Science Center. I was wondering if this is a place for water science centers to place published GIS data sets.
It certainly could be. I'll just mention, there's a lot of work that's going on right now through the Fundamental Science Practices Advisory Committee. I'm the CSS representative to the FSPAC, so I can speak about that a little bit, and the policy manual chapters on data release and what's appropriate for that. I was also involved in the recent response to the OSTP memo from February that was pushing government agencies, all science agencies that have, $1 million or more of research to get their data out publicly. So there's a lot of stuff that's swirling around in the Bureau right now in terms of where are the appropriate repositories and, what needs to happen with those repositories in order for data to be public and secured and managed and everything over time. And we're a part of all of that. Sciencebase is certainly acting as a digital repository for some groups as a primary store. An example is what I mentioned earlier, the John Wesley Powell Center. So as a partner of the Powell Center and as kind of part of their informatics arm, we're providing that capability for Powell Center groups that go through and release data. But, we're also not wanting to, preempt the other big repositories that are out there. I mean, there are science centers that have good capabilities at that level. There are obviously the big centers that we have from EROS and the shared LP DAC and the other capabilities that are available from there. There's the INWIS system itself that handles a certain portion of what the water discipline produces through time. So there are a lot of different repositories out there. Sciencebase is certainly one of those options. What we're working on this year is organizationally, how do we really position it? How do we set up what it is that Sciencebase can be responsible for? And how do we make sure that Sciencebase as a repository is really something trusted and a known quantity moving forward? So there's actually a whole ISO standard associated with trusted digital repositories, and we're taking a look at that in conjunction with our USGS library, figuring out, what does that look like for us, and could we sort of move to that point of maturity in this capability. So the fundamental answer is probably yes. This could serve as a digital repository for published data assets of a water science center like yours. I think we'd want to have a conversation with you a little bit about that first, about the limitations of what we have, the limitations of what we're doing, so that you're aware of that going into this, and that we, just kind of have full awareness of what we mean by that moving forward.
Okay, I've got 3 more nuts and bolts questions. Oh, sorry, go ahead. I've got 3 more nuts and bolts questions. If you want to tackle those now or wait until the end of the presentation.
Well, actually, if you wouldn't mind, if we could just kind of get through a couple of more quick things. Some of your questions may be addressed through that. I'm going to show one other quick. Unless Don, did you have anything else at this point, or?
No, that was it, and I can.
Okay, why don't you pass me the ball back. I'll have one other quick technical capability to talk to you about real quick. Then Tim's going to talk about just a couple of the future things, some of the challenges that we're thinking about. Those may answer a couple of more of your questions, and then we'll have a little bit more time for discussion there. Oops. Drop over to Google Chrome again here. So, as I mentioned earlier in the discussion about permissions and all of that, we set Sciencebase up in a hierarchy. You can see that here from the little breadcrumb on this particular item that starts at this communities level. There's a community in there for the National Geospatial Program, a collection for the national map, and then further sub-collection for the U.S. topo. At each one of these levels, permissions can be set by whoever has right permissions on these to determine who can access these. In this case, it's a public readable collection for the U.S. topo. It is manageable by a couple of service accounts, and then Steve Skelton in the NGP in particular has direct access to this particular collection to manage that. Sciencebase is now the primary store for all of the metadata associated with what the National Geospatial Program is calling their staged products, and we're on our way to storing all 2.5 million or so of those products within Sciencebase, at least the metadata for those, and in a few cases the actual digits, although they're working right now on extending that storage out to the cloud-based storage that is being sanctioned for use. But the metadata is coming together here, and we're now using these collections to drive things like the download framework through the National Map Viewer. Other ways of interacting with these services are being driven directly off of the Sciencebase API and the Sciencebase services that are available behind this. So I wanted to mention a couple things about this. So this collection has the 54,000 records, 54,365 current U.S. topos. There's another collection for the historic topographic map collection that has you know, the really historic record that has been scanned and made available there. If you look at the underlying record here, this is the JSON view of this. This is really how these records look in Sciencebase natively. They're stored in a JSON format. There's a section here at the bottom of every one of these documents called distribution links that really provides all of the different ways that an item can be interacted with. In this case, it's a collection item, so there are a number of different ways that this collection can be interacted with as a collection. We provide, similar to an upload of a shapefile, for anything that's a collection of geospatially referenced items in Sciencebase. Sciencebase provides a KML service, a WMS, a WFS for those, so that you can go interact with those similarly to how you would for, you know, any kind of a data service there. We also provide the native JSON way of interacting with the entire system through the API. There's an atom method for interacting with all of those child items that are within this collection, a CSV method that gets you back a certain subset of the metadata that can be flattened out. We've also now provided a PMH service, which is a type of protocol for harvesting the original metadata, and in this case it's actually giving you the ability to harvest that original CSDGM metadata that came into Sciencebase to provide all of these particular items, and a CSW service that's kind of a scaled down CSW search service that gives you the ability to tie that in with an OGC client in that way, as well as an ability to download any of the attached files that are associated there. So Don already really showed the basic functionality of tapping into these advanced services, pulling something up in Google Earth, dropping your WMS into another platform, so I won't go into that. But really these, what this means essentially is that for certain kinds of things that Sciencebase is bringing together into a collection concept, Sciencebase itself is acting as a database more than just a catalog. So this comes into play for a number of different things that we're doing in terms of driving, say, interactive mapping tools off of some of the collections that are brought together in Sciencebase in some way, and there's a lot of functionality that we're starting to get into behind that. But I just wanted to close the loop there on sort of the overall aspects of the geospatial functionality that's out there. So Tim, did you want me to skip over to you, or do you want me just to start showing the slides here?
Why don't you just run the slides? That way we'll save a little time.
Okay, oops.
Anyway, yeah, what Sky and Don talked about, a lot of the capabilities that we we have in Sciencebase. We also have a few challenges. We touched on these in some of the questions, but we also some of these, I guess we haven't talked about yet. First one we've had to deal with is people who have many data sets and metadata files. So that's the people who have hundreds and thousands of data sets as part of a collection, and how do they put those into a system? With any repository, that's an awkward problem. You're trying to make sure that you're documenting them properly, making sure that you're getting them organized properly. You also have the very large data set issue that Mike asked about. How do you upload large data sets? We have some users data sets between 70 and 200 gig, and possibly more when we get into the NetCDF world. We also have distribution of those data once they're loaded in. Once we're serving them through a repository, how does somebody get to something like that? The general file upload limits through a website is 4 gig, and the download is about 17 gig. I mean, you're going to run into problems outside of those things. So we're looking at unique ways to handle this. There's also the question of metadata. That's a classic problem with everybody. Redundancies, where we have multiple copies of the same thing in a large repository. Sciencebase has close to 3 million items. You're bound to have potential redundancies in there. And when we're addressing these challenges, Sky and Natalie Latish and Ben Wheeler, classic need versus capability versus architecture. You can start out with a need. As Sky pointed out, a user story defines what we build into Sciencebase, and that's the need. And you have to make a decision. Is that just some services you're providing, or is it an actual capability you're going to design into the system? And then once you're adding a capability, you have to decide, is that part of the core architecture, or is it a bolt-on? And bluntly, Don pointed out the ArcGIS edit services that we have. That right now is kind of a bolt-on. It's not part of the core architecture yet. So that's a decision. How long do we sustain it as a bolt-on, and how much, and when do we move it into the core architecture? Okay, next slide, Sky. So the first thing we want to talk about is the many data sets issue. So the way we address this, and this is Roland Vijay and Del Long came up with the idea of a Python library for Sciencebase. And this is basically PySB is what basically it allows you it allows secure access to items, like Don pointed out, to add things to your personal repository or your community repository, to get public items, many or one, to create new items or sets of items, to batch updates of items, and this is a way that we're using it to address when I've uploaded a collection and now I want to tag them all. Well, so how do I do a batch tag? This is one convenient way to do it. It is an open project. We're soliciting new methods from people, and it's and again, this presentation will be available to you. It's available through the MyOSGS Git repository stash. It's under the Sciencebase Experiments project. And already a few groups have already started working with it, and let's go to the next slide. I'm racing through this to try to get us on time. And the first is that there's a project that was completed last year, published this year, the Modus Phonology Toolbox, that was by Colin Talbert. And it's built on ArcGIS image services. It's an ArcGIS toolbox. And with PySB available, we're going to be looking in FY14 to basically expand some of the capabilities on this. But it's available now and if you go to Sciencebase and search on Modus Phonology Toolbox, you'll find the publication and the attached actual toolbox like that, but we're going to be retooling it. The Metadata Wizard, that was a CDI project headed by Drew Ignacio and Colin Talbert, as well as the rest of the GIS group at Fort. And there's no upgrade in progress, but OFR in progress. But they're also going to be looking at tying into the PySB library as far as basically metadata creation to work with different components. And we have a couple, now this isn't just limited to PySB, but we're seeing a lot of mobile support and collectors, a lot of collectors, in fact the Esri collector, some work in that respect, working against the Sciencebase REST API thing to note. As Don pointed out, Esri's collector just needs a transactional web feature service, which Sciencebase provides. So it's a convenience. You can load items into Sciencebase as your base data set to have your collector work against. Other mobile support activities are Forest Service is working with the USGS on one that's working right now against Sciencebase. So these are a variety of deals, but we see some opportunities with some of the open source libraries that we're going to be creating to help these mobile groups actually do some mobile technology in support of science. Next slide. Okay, we had a problem. We have a problem with very large files. So we don't really have a good answer. This is, as Sky pointed out, some pilot work. This is where we set up an Amazon S3 space where you can use some third-party tools to push data sets to those project spaces. We still need to develop a programmatic way to register it when you stick it into your S3 community. That's a technical issue. We haven't worked on that yet. Right now, everything's by hand. We need to expose the Sciencebase tools to serve data from S3 like any other Sciencebase item. Now, that isn't a technical issue. We know how to do that. We've set that up. We can do that just fine. That's an administrative issue. As Sky pointed out, we're still wrestling with the cloud contract, how we're going to handle that. We have some new information today, so it looks like it's going to be a lot smoother going after, well, this week. There is no solution for a user with inadequate network topology. They can send a hard drive, that's sort of lame, but that's all we got. Next slide. Metadata. We know that quality discovery depends on quality metadata, and that's, your metadata stinks, nobody's going to find your stuff, and we do have that issue. Mike Frame in the CDI call today talked about some rubrics that they're going to be implementing, some ways to try to gauge metadata. The CDI data management team is really working through some process solutions to go with the technical solutions. And that includes not just the metadata wizard I just mentioned, but also the CSAS metadata, online metadata editor, and some different support concepts that Viv Hutchinson, Lisa Zolli, and some others are working on. They're going to be developing with some other groups, some workflow examples for the data management site that they've posted. So this is hopefully we're going to be a combination of some technical solutions and some human factors solutions to try to get this solved. Next slide. And finally, dealing with redundancies. We mentioned earlier, you have a large catalog, you're going to end up with multiple entries of the same item in a search. It's frustrating. We know that we have a lot of work to do in this regard. Duplication does not always get you where you need to be. For queries, you may have some slightly altered metadata, checksums and file sizes. It's a starting point. So basically, we see this, like data management, as being a combination of technical and human solution to try to work through. There's a lot of items in Sciencebase. We expect a lot more items this year. So this is going to be an ongoing issue. But just want to let you guys know, we don't have answers to a few problems. And we are looking to this community to help us with suggestions, with technologies, with anything you guys have discovered that may help us with some of these answers. So turn it back to Sky.
Great, thanks, Tim. And I'll wrap up here real quick. So I think we've already hit on a lot of this in terms of the scope and scale kinds of issues that I was going to mention. But again, I just want to put this in context for you that this is a core architectural capability of the Core Science Systems mission area and managed by the Core Science Analytics Synthesis program in particular. We're using it for a lot of different things, and we're continuing to explore exactly how it gets positioned in the USGS as an enterprise capability, and really move forward on that here in the next, we'll be moving forward with that pretty quickly here in the next number of months of this fiscal year as we solidify things. A couple of other contacts Tim mentioned there, in particular Natalie Latish is really the project manager, product owner for Sciencebase. She really oversees the development backlog, and what goes in there is having a lot of the interactions with our communities that are working in that world. And then Ben Wheeler, who Tim also mentioned, is leading an effort called the Science Data Lifecycle Framework, which is kind of the overall umbrella project that has things like the metadata editor that Tim mentioned as well, the Science Data Catalog, Data Management Dashboard, a bunch of these other related pieces in the sort of data management cadre of things that our Core Science Analytics and Synthesis group is working in. I'm currently in a little bit of a different role. I was, I think, the original visionary behind a lot of Sciencebase and have been driving an awful lot of the architecture for quite some time, and I'll continue consulting on the project moving forward, but there are really a whole other cadre of folks that are leading this and moving along. And CSAS is very much in partnership on this with the Fort Collins Science Center that is funded by a number of different areas, mainly the ecosystems mission area, but also through us and is a partner with us in moving this whole thing forward. And the Fort group has been absolutely fantastic in getting the word out on what this whole program is about and what we're trying to do here, interfacing with a lot of other groups out there who are using Sciencebase in various ways, integrating it into other programs and projects that Fort is involved in. And so we're very much partners in moving this whole thing forward and figuring out where it's going to go. And we're looking for other partners involved in this. One of the major things that we're trying to get done here this year toward that Constellation edition that I mentioned is to get the Sciencebase code base much more modularized and fully out into the open source space, even beyond our MyUSGS open source space, out into GitHub, so that we can really receive other commits back into that over time, have people branch off, fork the code, go do some other things with one component or another, and then weave that back into the trunk over time. And so you'll see that coming about hopefully over the next while. We're partnering with a number of different groups around USGS to kind of explore what that looks like for us, what we really need to do to run this much more as an open source project, as opposed to just releasing our code, which we've done a couple of times. But we certainly want to let people collaborate, pick up a component and work on it in some way, but that means we need to componentize things a little bit better so that it makes sense when that goes on. So I don't know what we have left in terms of time, Steve, but if there is any time for further conversation, we'd welcome your questions and discussion and comments.
Well, yeah, if you don't mind, the bridge is reserved for another 20-odd minutes. So there were some nuts and bolts questions about Sciencebase. Two people were asking about geoprocessing services. For an example, what was it, a clip and ship type of service?
Yeah, we've got some examples of that. Tim or Don, you want to jump in on the GPS stuff?
Sure. If you want to, it might be easier to share my desktop, Sky, if you want to pass me the ball. But I can talk about it too. That would be one of the things that Tim referred to as a bolt-on thing. If you want a Esri sorry, I'm just setting my desktop. If you want a geoprocessing service, that would be something separate that we would set up. If you're just talking about being able to download the actual data, then that kind of can already be accomplished through Sciencebase just on clicking on the item that you uploaded to Sciencebase. That is one way to get it. But we've definitely set up, I can show you something for the modeling of watershed systems. So we did set up a special geoprocessing service for the Modeling Watershed Systems project. This is a way that we made the entire water catchments for the entire country available online. You can zoom in this application. You can be interested in any catchment that you want. You find a stream gauge that you're interested in. You can open a geoprocessing service, and you can essentially put in any of these numbers, and what it does is calculate all the upstream catchments from the one that you put in. And after you run this, it cycles through the whole huge file geodatabase behind the scenes, and it spits out a file geodatabase to the end user of just those upstream catchments from you're interested in stream gauge. But yeah, you can also do simple clip and ships. This is a complicated Python script behind the scenes, but that would be kind of bolt-on stuff to Sciencebase, like Tim was talking about.
Yeah, but it's actually one of the new item types that we've been considering and thinking about what that means. So if, again, an item is an item is an item, if an item is a processing service or an algorithm or another type of packaged process of some kind, and of course there's a lot of different flavors of that if you look across the spectrum of sort of what we deal with. How can we start treating those as items that can interact with other items, be strung together into some sort of a workflow? There's a lot of things that we'd like to do there that are sort of in our research pool right now in terms of thinking about how we fully integrate that into the Sciencebase stack. In the meantime, as necessary, and working with great partners like Roland and the Mose Group, we're certainly willing to take some things on, because what they do is they help us, we might bolt it on for a little while, but what that does is it helps us explore, all right, how would we go about integrating this into the core technology stack as something that can be used much more writ large.
Speaking of Roland was kind of curious about geodatabase support.
As an uploaded file type.
Yeah, and as Don pointed out about other things, geodatabases as an uploaded file type, by default, it's just available for download. Again, it doesn't do anything with it. But as Don also pointed out, we know that anything that's renderable via an Esri ArcGIS server defined service is going to be available outside of just the download. You'll be able to register a service there. So again, as Don pointed out, kind of a bolt-on right now, something that's being considered. There was we had a long time before Esri released the standard for geodatabases, so we didn't catch up on that yet. We're sort of waiting for the open source tools to get a little bit more reliable in handling them before we do that programmatically.
Right, but when you set up your service definition file upload to Sciencebase, if one of your data sets actually references a file geodatabase here, you can create your service definition file based on that, and that will get zipped up and get uploaded and start a GIS service on ArcGIS server. So you'll be able to serve pictures of your data in file geodatabases, no problem right now. But if they're just uploaded as a standalone file to Sciencebase, yeah, then Sciencebase can't really read them.
So just a touch of indirection to get this to work. You just have to package your geodatabase into a service definition file.
Yeah, I think what we'd want to do is explore some explicit user stories around what would need to happen on the other side of a geodatabase upload. I mean, a raw geodatabase upload. I mean, the advantage to putting it into an ArcMap project, organizing exactly what that thing looks like, providing some symbology work, and packaging everything out as a service definition is that, you get something at the end of that kind of is a fully functional online ArcGIS REST service or WMS, WFS, whatever else is available behind that. But just doing a geodatabase means, well, okay, what are you going to get out the end of that? What do you want that thing to do? How do you want it to be served? Can we reliably provide some sort of across-the-board symbology that's going to make sense or not? We kind of don't think so. So this is the method that we're supporting right now. But it'd be great to explore some specific user stories and some expectations for what might happen with something like that.
Yeah, and I got to say, I asked that question before Don introduced that service descriptor stuff, which I had not heard about. I think is pretty darn interesting. Definitely worth an exploration. So my question might have been moot.
Cool.
Anybody else?
Is it possible to just give us kind of a quick clarification? We're struggling a little bit with just the relationship between the Science Data Catalog and Sciencebase as far as use cases and just the interaction of those two.
Yeah, sure thing. I can do that. So the Science Data Catalog is really something that is still developing and moving forward pretty rapidly in terms of what it is. But it is the response, really, of the USGS to the open data directives, mostly the OMB M1313 directive from last year and executive order in that in terms of providing our data inventory. Technologically, the Science Data Catalog is a combination of two things. It's a combination of Sciencebase on the management side of exposing or sort of registering given data sources for use by the Science Data Catalog. And I'll tell you a little bit more about that in just a second. And then the Mercury technology from Department of Energy, Oak Ridge National Lab that we've worked with for quite some time in terms of indexing those materials in a particular way to provide the front end and search interface and output from that. So we ended up putting a couple different technologies together to get to the Science Data Catalog. So there's a data management dashboard piece, which is where users come in, register a given data set or a given data source of some kind. It can be either a web accessible folder, a site map, or an existing Sciencebase collection. What actually happens now then behind the scenes is that all three of those, if it's an existing Sciencebase collection, maybe it's being managed through some other process within Sciencebase, either via uploads or one of the other harvesting methods that we have. Then that's immediately pulled out into the Science Data Catalog index from that point. If it's a WAF or a sitemap, we actually register that in Sciencebase. Those are the records from those are harvested into Sciencebase, and then they're provided out to the catalog from there, the catalog indexing process from there. In all of those cases, we're actually using what I pointed to there earlier, that OAI PMH thing, the protocol for metadata harvesting, as the method of going from what's in Sciencebase out to the Science Data Catalog indexing process. Does that help a little bit? I mean, Cassandra Ladino, I think, asked a